Hi, this lesson is on geomorphological processes that impact the coastal landscape. Not always talked about geomorphological, geo meaning like geology, geography, morphological meaning shape. I would say you could probably break this down into two further subcategories, sub-aerial processes and marine processes. The top two here are sub-aerial processes. I'll deal with that in a subsequent lesson, weathering mass movement, along with things like infiltration, runoff, and they impact landforms, cliffs, etc. And not totally independent, but you'd say that they're a separate set of processes, whereas marine, meaning the sea, is where the action of the water can erode it, can transport material, and can deposit material. This lesson will focus on the marine processes. So marine meaning the sea. And the first one I'll deal with is with erosion, followed by transportation, followed by deposition. It is important to get these terms correct, for accuracy when you get asked these things, but also in the longer essays where they might say assess the relative importance of marine processes versus subaerial, or even more specifically erosion versus weathering. If you don't know the distinction, that will seriously impact your score on the essay that you get. So do take time to learn these words. Now, the basis of erosion is where we got it's the breakdown, simultaneous removal of rock by water or wind. Wind definitely operates on the coastline, but I would say in the coastal landscape units, the coastal environments, you tend to focus more on the action of the water. And the water is moving, hitting and breaking and removing material with a variety of processes. Okay, there's a clear distinction between that and weathering. The next slide, I'll show you 5 key types of erosion. I'll do like a summative bit on the slide and then I'll go through them a little bit more specifically. So the first one I'll deal with is with attrition. Here, this is where, in the swash and the backwash of the waves, longshore drift, wave action, constructed district or whatever, rocks move backwards and forwards, they collide with each other and other surfaces, bits break off, they chip away, they become smaller, more rounded. And in some instances, there are bays where on one side you've got large angular rocks, and by the time you get to the other side, longshore drift carrying it, they can be like grains of sand. That is possible. Beach sediment can be formed by attrition, and this is largely where the material is ground down. And with this process, you're not usually talking about the like cliff recession or the formation of an arch. So 3 words there: hydraulic action, quarrying, and cavitation. 3 high energy words. I'll deal with quarrying a little bit later. Hydraulic action and cavitation are often connected together, often happen in the same sort of environment, large waves coming in, energetic waves at least. And hydraulic action has several parts to it. You might say the sheer force of the wave comes in and crashes into the cliff, causing like breakdown of the rock. But I would say more importantly, you'd say as the wave gets close to the cliff, and if the cliff has cracks and joints and bedding planes, air gets compressed into those cracks under high pressure, and then when the wave goes back, that decompresses, that weakens the cliff, and parts of the cliff break away, and therefore you've got hydraulic action causing erosion, and that can be highly effective and do a tremendous amount of erosion to the cliff face. Cavitation is more about air bubbles, and again, I'll wait to the next slide to show that. Solution is sometimes called corrosion. So certain types of rock, particularly things like limestone, will react with the salts and the acids in the water, carbonic acid being an acid, and they'll slowly dissolve. Okay, so this won't be as spectacular as hydraulic action, but nevertheless exists with certain types of geology. The next one here is abrasion. And with abrasion, sometimes known as corrasion, I just stick with abrasion mostly because it just simplifies things for me. This is where the waves pick up material, large or small, so rocks, can be grains of sand, and it gets hurled, thrown at the face of the cliff. And on the larger parts and pieces, they'll scour out the cliff, break off divots, and that causes recession. But also, if you've got fine grain sands that have more of a sandpaper effect, like I'm rubbing my hands together here. So just to visualize this a little bit more here, you can see here, big wave coming in, and you look at this figure here, 30,000 kilograms per square meter. That's not always the case. That's can be. Depends on the size of the wave, the speed of the wave. And that does tremendous amount of eroding, high energy. If I now move on to the next bit, which you might not have been taught, certainly you don't rarely talk about this at GCSE. The essence of cavitation is, and you saw in that last photograph, all those white water in the waves. They're air bubbles. They're formed when the water is turbulent. And what you've got is all these air bubbles, and eventually they implode very, very quickly, and that sends out shock waves. That will get you by on it. I've heard other people say sometimes when the air bubble collapses in the water, it creates a jet of water in the water as well, and that can disturb the rock and adds to the impact of hydraulic action. Both of those are high energy. Don't see this with all the exam boards. Wave quarrying, this is where the force of the wave hits the base of the cliff. The force of it, vibrations it causes, weakens the rock, dislodges it. I've heard words like, again with wave pounding, like almost like it's being quarried out, scooped out at the base of the cliff. Again, high energy. Then coming back to this one, I use abrasion. Again, large or small sediment thrown at the base or at the cliff itself, and it breaks off pieces. The finer the material, the more sandpapering effect, I would say. So you'd see maybe a more smoother surface. On this slide here, the focus is that, carbonic acid, so CO2 reacts with water, forms a weak acid, reacts with calcium carbonate, and breaks it down and in solution, so it kind of like moves away like as a formed liquid. And then just visualizing, I'm not saying you're going from this to this to this, but it's more symbolic than anything because they're from different geology. Larger rocks become ground down, pebbles, and eventually, technically speaking, could be this. And that's what, the sand you might be walking on may well have been formed that way. Now, moving beyond this, we'll now look at the second set of marine processes, transportation. So this has been included. Aeolian is another word for wind. You would talk about this to do really more to do with sand dunes. So that is in most specs. The focus here is on marine transportation. So how the sea moves material, often the eroded material. So you will have learned that waves, when they break, they have the swash that goes up the beach, and the water coming back down the beach is your backwash. So sediment gets moved around in that fashion. And if the swash is stronger than the backwash, more gets transported up the beach, and therefore the beach builds. It's constructive waves. And if the backwash is stronger, combined with maybe a plunging wave, material gets moved off the beach. So that's something to consider in some of your answers. Now, a combination, and we'll definitely see this, is where you have where swash comes at an angle. Oblique means 45 degrees. The reference of that is to the theoretical pictures that you get in the book, where the prevailing winds are coming from the southwest, and the prevailing winds dictate the angle of the wave. The wave comes in at that angle, breaks, the swash goes up the beach at a 45 degrees oblique angle, and then comes straight back down due to gravity. And across the beach, but also in the water, material is moved, a current's formed. Okay. Furthermore to this, you get local currents that move along the beach, might be from a river, might be coming from offshore, and they can remove sediment. Also, a rip current, whereas there's a net buildup of water which goes out to sea. They're those dangerous currents. They can move sediment. On this slide here, what I'm showing you here is and again, it's well worth learning this, is the action of longshore drift or littoral drift. So this would be the prevailing wind condition. The waves would come in at the same angle. They break. They go up the beach at an angle because they have energy. They're going upslope the beach. Then they run out of energy, overcoming friction. deposit maybe some material, but often we use the proverbial stone, goes the beach at an angle, then goes free wheels it down under gravity, straight back down, quickest route, and picked up again. And the process is repeated, and you get this zigzag-like nature of this. Very important process to remember for your beach formation, for your spit formation, and all the variants of that as well. And you'd also have a net current moving in this direction. You may have experienced it when you've been in the sea and your family's on the beach and you're thinking, I don't remember moving, but I seem to be 50, 60 meters away from my original position because there's this current. And triathletes also have to put up with, well, when I say put up with it, actually, they call it downhill swimming because this current that's generated can speed you up. This particular slide looks at more specific forms of transportation. So here, what we've got here is traction. Again, you've probably done this at GCSE, both in rivers and in coasts. This is the larger material getting under high energy. It will roll. Think of a tractor, the big wheel turning over on the ground. Boulders will roll over on the seabed and move forwards, high energy. Moving across it in the next order on the seabed, small pebbles, grains of sand will bounce and one will knock into another, causing a reaction. So like leapfrogs across. And then when the material becomes finer, so silt that gives it that muddy color, this is churned up. If you're given enough time, if the conditions are calm, this then drops to the seabed and the water goes clear again. This is lighter. And then solution, you can see there's almost like this very sort of opaque, sort of like cloudiness. This is where you have minerals in the water. They're so small, they never settle. Sometimes, if you hold up a glass of mineral water, you can see a little few glints, a few speckles in the water from the shine, the reflectivity aspect. It's so tiny, this stuff never settles. So, it depends on the geology of the area for how much of this is in the water. But there are four techniques there. Finally, coming on to this particular one. So deposition. So this is, generally speaking, tends to be low energy. So if you're going to get deposition, and I alluded to this earlier, on a beach, if the swash is stronger than the backwash, material's thrown onto the beach, depositing it, doesn't then have necessarily the energy to pull it off the beach. So the swash is stronger, probably a spilling wave which carries forwards, and then the backwash as it comes back has really diminished energy and therefore doesn't have the ability to pull much of that material off the beach. It has more of a spreading effect. Sort of conditions, shelter conditions, so calm conditions, and I think like in an estuary, in a bay, so sediment can get trapped where it's calm. Other things behind a spit, so like a barrier in front of it between the deposition and the open sea. Salt marshes where there's vegetation trapping sediment, slowing down the water. For deposition to take place, you do need to have sediment, so maybe longshore drift is transporting material there before it gets deposited. So it actually provides the substrate for it to actually drop on the seabed. And then again, this is another source of sediment for deposition. There might be erosion coming off the cliffs, or it might be deposited off by the river and then sort of forms in a calm environment. And again, this just talks about how you get sediment. So this isn't really about deposition, but again, just providing information about how maybe cliffs get broken up. Then it goes into longshore drift and then it gets deposited in a calm environment. Being slightly more specific, if you're wanting to use some more buzzwords, gravity settling. So if you just read this out here. So where the energy of the water becomes low, too low to move the sediment, through gravity, it just drops to the seabed, right? Whether that's pebbles, sand, or silt. Okay. Now this one here is more of an interesting one. You rarely probably use this. It's called flocculation. You definitely use this with salt marshes. You would use this with, some of you in your syllabuses will do deltas because it's on the coastal area. This is where when fresh water carrying clay, when it hits salt water, you get what like a chemical attraction, electrical attraction, cation exchange, I think, if you're into your chemistry. And what happens is the clay particles stick together, they clump, and as a result of that, they get heavy and then they sink to the seabed. You definitely see that in things like delta formation. And if you're doing Edexcel AQA, you don't really worry about that. But certainly with salt marshes is something that I would be talking about. Okay, so in essence, they are the three marine processes erosion, transportation, and deposition that you need to learn about. Part 2, I'll go through the subaerial process, which I talked about at the beginning of the video, and I will make it really clear about the difference between that and subaerial processes and marine processes. Thank you for listening. I'll see you next time.